Hello, welcome to a demonstration of the texture processing functionality that's now been added to the EDeN project. It's been a few months since I've posted an update, mainly due to family health and moving home. I finished most of this work in end of June, and I've resumed this last week. So, to recap, we have a C# interface that's unique to the server. However, both server and client have a Python interface, and for internal testing purposes, it's also a C++ interface. For speed of demonstration, I'm using the C++ interface. I'll be demonstrating that shortly. Before we get started, just to explain some new features. On the right hand side, there's now a connectome cam, and so previously you may have seen in the posts that the connectome was kind of in your face, connectome rendering in your face on boot, and now it's off to the side with some layer processing, so you can either inspect it pressing C, or you can just see how it's going on the right hand side. So what we'll be doing is running a simple test whereby we're only running limited the entity to 27 vector units, and limiting it to only one process node. What that means is it can't really do anything, it can't react to the environment, but it takes mere seconds to demonstrate. And I'll explain the importance of more connectome, a larger connectome, after the demonstration. So if you've been seeing previous posts, this interface may be familiar. As you can see, we've got mlist, handwritten digits test, and a Python test. So effectively all these variables are setup variables. If you read the original paper, these variables are mentioned. Effectively these are definitions for the initial state of the entity. However, beyond that, it grows within the boundary of its genetics that defines on these initial conditions, and interacts with the environment. Now the most important aspect that's been added recently is this set texture 2D command data, and you can see what we're going to be doing is spawning the entity position. In this case it's a little robot that gets spawned, and a render object location, and that render object renders the texture that we want to train in the real world, so that the robot can, or the entity in this case, can take a picture of that and activate its neurons on the client side. So effectively it's a setup and then stream, and as explained in the paper, what we're doing is we're giving the entity stress using the inputs from a camera. It could be audio, it could be other stimuli in the future, to get it to do something useful, or die, and or hopefully create offspring. So I'm just going to run this now. So what it's doing is generating the functome from those initial conditions. These numbers look a bit random, but they basically define those the entity. And you can see we've got a lot of warnings, and these warnings is due to, as I said previously, the constraints we've added in these hyperparameters. Now, because we've set it to only allow one process node, that is effectively a neuron body, it's trying to grow from that one node, but the constraints of the entity's size is limiting that growth, hence these warnings. Here we've got an output probe location, so that's just setting up an area for you to probe the entity's waveforms as we train, and likewise we have input links up above. Part of the test also is decoding, so these initial variables are actually encoded into the entity's genetics to make it easier to easily pass around a file if you wanted to provide this entity to to someone else, so you could regenerate it under different conditions or on different machines. So what I've done here is it's stated we've retrieved the data here, and you can see we've got 91 axon terminals, 113 dendrites, only two neural containers, 4 input links, 1 output probe, and 2 process nodes. So very limited. And you can see in the engine that matches the rendered connector. So I'm going to press C so we can look inside it. And it's kind of just a green blob, and that's because we only have 27 specified space here, so therefore you don't really see a pattern here, therefore the connector render doesn't really demonstrate much. Now in larger entities you'll be able to see the growth patterns of clicks of neurons interacting with each other, which will become very helpful. Now you can see on the right hand side also we've got current dataset info. Now what we've done is we've, in that command structure, requested a dataset to be loaded and a random sample to be selected. We've also instructed it to create this cube in the training environment and obviously clone that image to it. We've also then, as shown earlier, we've got a little robot here, and with the name of the test above it. Doesn't really do much because, as I said, it's quite a small entity, and you can see it's bright on the right. So the idea is that when we have a camera on these entities' eyes, it will see the environment, activate the input links, and hopefully we'll see the neurons reacting, and it moving at first in a sporadic manner, and hopefully with more focused interest in the future. So the goal here, for the moment, is just optimization and making it more user-friendly. And the next stage is the MNIST test, which is effectively getting it to respond to images of handwritten sizes, which is a common benchmark in normal AI world. If you're not familiar with it, there's plenty of resources out there, and NVIDIA and I believe MIT. In AI terms, it normally only takes a few minutes to train this, or to at least see behaviours from handwritten digits. So that'll be the next stage, and I look forward to posting that up. If successful, that's not the end stage for release. After that will be optimization and trying to test on many different devices. Currently Windows only is supported, but I'll be hosting it on a VM that will be running through AWS Marketplace. Okay, thanks for listening, and I hope this has been intriguing.